Welcome to 3.5 bisectors. We're going to start with some definitions. Perpendicular bisector is a line ray or line segment that is perpendicular, right? It forms a 90-degree angle with the line segment through its midpoint, making it congruent, so it's bisected. The first theorem is if a bisector of a segment, it is equidistant to the endpoints of the segment. The idea is here, if you have a line, a bisector through a segment, you can connect the points from P to A and P to B, and those would be congruent. Essentially, you're forming an isosceles triangle with a perpendicular bisector that goes through the vertex of the triangle. We also can do the converse, so if it's equidistant to the endpoints of a segment, you have an isosceles triangle, then you can draw a line through the vertex that is perpendicular and bisecting. Okay, so how to use this? Well, here we have a perpendicular bisector, it goes through the vertex, so then these two side lengths are in fact congruent, so their lengths are equal. So 4x equals 6x minus 10. Subtract 6x, we get negative 2x. Divide by negative 2, we get 5. Okay, so x is 5, so what is the length of AB? Well, AB is 4 times 5, which is 20. The concurrency of perpendicular bisectors. So if three perpendicular bisectors meet, it's called the circumcenter. The circumcenter is actually, what it does is it makes equidistant from the vertices. So from the circumcenter to the vertices of the triangle are the same length. Because they're the same length, you can draw a circle around the triangle, and the center would be the circumcenter. Circle means to go around, so you can draw a circle around. They can be inside, outside, or on the triangle. In an acute triangle, the center is inside the triangle. On a right triangle, the circumcenter is on. In fact, it's on the midpoint of the hypotenuse. In an obtuse triangle, the circumcenter is outside of the triangle. Our next is an angle bisector. It's a line ray or line segment that bisects the angle, creating two congruent angles. So the next theorem we have is if a point is on the bisector of an angle, then the point is equidistant from the sides of the angle. You have to consider that it has to be the shortest path possible, which is a perpendicular line. So here, if we have an angle bisector and we have two lines that are perpendicular, then we know they're congruent. The converse of that is if we know that they're congruent and perpendicular, then we can draw an angle bisector that goes through the last point there. How to use that? Well, we have angle bisectors. We have perpendicular, so we know they're congruent. 7x equals 2x plus 25. Subtract 2x, we get 5x. Divide by 5, we get x equals 5. So then it wants Rm, and Rm is just 7 times 5, which is 35. The concurrency of three angle bisectors is called the incenter. The idea here is that the incenter is equidistant from the sides of the triangle. And of course you take the shortest path possible, so it's perpendicular. And because they're perpendicular and equidistant, we can draw a circle inside the triangle. It looks like this. So incenter is like inscribed circle. Makes it congruent and right. How to use this? Well, here we have perpendicular lines. We have angle bisectors, so G is the incenter. We know that GE, GF, and GD are all equal or congruent. So we can set GE equal to GF. So 2x minus 7 equals x plus 4. We're going to subtract x from both sides, and then we're going to add 7 to both sides, and we get that x is 11. To find GF, well, we know that they're all equal. So we can substitute into either one. I'm going to substitute into GF and do 11 plus 4, which gives me 15. So I know that GF is equal to GD, so GD equals 15. So that's everything for bisectors. Good luck in the practice and application.